Alright, welcome Year 9 to a video on the angle sum of polygons, and I'm going to use this PowerPoint here along with some other things to help us out with what this section is all about. So firstly, let me just have a look at this first slide, and dealing with polygons, it says first what a polygon is and what it isn't. So you've got to have straight edges. Let me just change that colour. No, I can't. That's okay. Straight edges like triangle, square, these two are both polygons. Not a circle or a semicircle because they have curved edges. I am going to change the colour. Let me just go there. Okay. Now, convex. That's the next thing, is difference between convex and non-convex, because you'll need to know. So a convex polygon, this one, all the vertices, angles point outwards. So if we make an arrow using the angle, you see the arrow is pointing away from the shape. This one here, arrow, that's what that means. The angles are facing outwards. Diagonals are all inside the shape, so diagonal from one corner to another, they're all inside, and all angles are less than 180. Some of them are acute, some of them obtuse. Most of these look like they're obtuse, that's okay. So that's the convex one. Concave one, which is some vertices only need to have one, but some of them are angles point inwards, like this one. So if you make an arrow using the angle, the arrow is pointing towards inside the shape, so that makes it concave. All these other angles are pointing outwards, but that one's pointing in. That's all you need, just one. Some diagonals are outside, so from a corner to another one, that's all you need for a diagonal. There's a diagonal there, outside the shape. Another diagonals, oops, let's go back. Let's go that again. A diagonal here is inside the shape, but that definitely outside. Okay. Next slide. We have the angle sum, which is the main focus of this part, and it gives us a formula here which gives a connection between all of these, so we can work out the angle sum of all of these. We know that a square, any four-sided figure, the angle sum is 360. And we know any triangle is 180. Well, there's a connection. This is the connection between all of them. So basically all we need to know is know the number of sides, and we can work out what the angle sum is. So for a pentagon, five-sided figure, we'd go 180 times the number of sides, 5, minus 2. 5 minus 2 is 3, so 180 times 3 is 540. So that's the angle sum of a pentagon. Hexagon, 180 times 6 minus 2. Because number of sides is 6, 6 minus 2, that gives us 720. Hopefully you'll see a bit more of a pattern too. Heptagon, that's 180 times 7 minus 2, which equals 900. So all the 7 angles in a heptagon, the total of all those 7 angles is 900. Octagon, 8-sided, 8 minus 2. That'll be 1080. The 9-sided figure. I'll just do it without the formula now. That's 180 more than that. What's that? 1260. And 11-sided figure, the decagon, 10-sided, sorry. That's 180 more than that, which will be 1440. The 11-sided finger, decagon, 180 more than that. That would be 0, 2, 6, 1. I think 8, no, 5, 2, 1. Sorry. Let's just try that again. Let's get our rubbing out right. So that was 1440. So the 10 angles in a decagon total 1440 degrees. Decagon, we just add 180 to that. 0, 12, yep, that is 1620. And finally the dodecagon, 180 more than that, is 0, 10, 1800, 1800. This you'll need to write down because that comes in handy for answering the questions. So that's the angle sum of all these polygons, and it's the same every time, regardless of how the polygon looks. Okay, next thing, irregular polygons. So I'll just go erase all this. So, regular polygon this time. The concept is that a regular polygon has all angles equal, all sides equal. Just like, if I can do it accurately, equilateral triangle is a regular triangle. A square is a regular four-sided figure, or four-sided, and also the rhombus. All four sides equal, and so all angles inside are the same. This one here, pentagon, all 5 sides are the same length, and all angles are the same size as each other. Now, this here is a little bit confusing, so let's just use the pentagon as an example. The size of the angle in a pentagon, that would be the angle sum, which I think was 540. So the angle sum of a pentagon is 540. That's it. Number of sides is 5. That equals 108. So each one of these 5 angles is 108 degrees each. Hexagon, 6-sided figure. That would be, angle sum of that is 720 over 6. That equals 120 degrees. So each angle in a hexagon is 120 degrees. So that's how you work that one out. Now, let's go back to the textbook and see what else it has for us. I'll just get rid of all this. So we've got just got to get rid of all this. Okay. So question 2 is the first one. Name each polygon. So just count the number of sides, and according to our PowerPoint, once you've numbered the size, you'll be able to name it. And then question 3, which of these polygons are convex, which means all angles point outwards. and which ones are regular. So every angle in the polygon is equal. And part 6, I think was the next one. Find the angle sum of the polygon with those. Well, we've answered that back in the PowerPoint, except for the 20-sided one and the 15. So what you'd have to do is the number of sides, 180 times, say that one, the number of sides minus 2. So 180 times 13 will give you that one. So that's how you do question 6. Question 7, we've got firstly to count the number of sides. 1, 2, 3, 4, 5, 6, 7. 7-sided figure. That should have an angle sum of, let's see if I can find it. PowerPoint. No, I can't get it. You'll have to look back on what you've written down to find out what the angle sum should be for a 7-sided figure, and then find out what the total is, and what's left to get to the answer there is the value of each pronumeral. So these ones, we've got 2 different ones. They're both B, so they're going to be both the same. 5-sided figure, that was 540. And we've got these many angles so far, so what's left divided equally amongst those 2. We just answered that one a minute ago about the pentagon. So count the number of sides, work out what the angle sum should be, and then find out the missing amount, and that'll be according to the pronumeral. Some of these have got equal divided, like this one is. This one is by itself, and so is this one. So that's how you do question 7. Thank you.